Well, we have moved back outside into the proper workshop so we can do a bit more, perhaps, real-world testing with the controller we have built here, or assembled rather. I thought I would bring it out here and give you a brief sort of rundown and I go through all the bits and what they do. So at the moment I have this bulb here is going to pretend to be the fuel pump. This bulb here is going to pretend to be the fan for the blower, the burner fan. And this bulb here is going to pretend to be the glow plug. The big 5-position switch in the middle, and I'll go through all the wiring bits in a minute, but I thought I would just give you a brief sort of oversight. Hopefully that's staying shot. Stay. Please stay. Please stay in shot. Yes, okay, right. So, position 0, nothing, off, nothing is happening. Position 1, which would be cool down. So, position 1 puts the output fan on. I can't remember how many volts I've set it to. Some quantity of volts for cooling down. It also preemptively starts the fan spinning so we can bring it down to a lower voltage, because sometimes you need a high voltage to start the fan and then it can run at a lower one once it's started moving. So that would be the fan on. So that's cool down. Then we move to start. On start, you'll notice that should have appeared dimmer in the screen. You can see the fuel pump is ticking away over here, and the glow plug bulb is on fairly dimly. I think at 10 volts, 10-ish volts, so as not to overdrive the glow plug. So that would be your start, where it's giving it fuel, glowing, and a little bit of air. And then it then switches to low, glow plug's gone off. That should have got a little bit brighter, and this is going a little bit faster now. That's low speed, and then high speed. That should have got brighter, and you can see that's flashing away a lot faster in the background. So that is that. Now I will bring you in and we can go through these bits. I will take you off the tripod and we'll go for a walk into the wiring. So first off is this big block I have at the bottom. This is all of the positives tied together. They come straight off the battery and power supply. So all the positives are in this block here, and that's the positive goes out to one half of the fuel pump. Positive goes out to one half of the blower fan and one half of the glow plug. All these positives are then tied into one side of the switch. So basically all of these connections are just the same positive. It's just all positive, all joined together. Because all you're doing with the switch is making the positive go from this side to the other side, which is the output to whichever device you're going to. Up here, this monstrosity of multi-blocks is all the grounds. So that's just the ground coming off the battery power supply and just loops in and out a lot to be all the grounds. The grounds from that don't go out to anything else, obviously, because these are the ones that we are actually switching to drive the pump and the fan and the glow plug. So all of these grounds, these little thin wires, these are the ground wires that go to all of the modules. Each one's got a positive trigger that comes from the switch and a ground, and then the output that tells the MOSFET to turn on and off. We've got start, low, high for the pump. We've got one for the glow plug, and on the other side we've got cool, start, low and high for the fan. And that is the 555 timer PWM modules. Now each one of these, you'll see, so we'll do fan first. Cool, start, low and high. And all of the trigger wires come out and they all join into, excuse me, I will move the MOSFET out of the way, into this multi-block here. The diodes that they come from, so this is the feed coming in, they go into the diode and then into the block. The diode's there just to stop any signal coming back the way, because it would come back and it would then re-energize another module from the signal from the other one, so it got a bit of a confusing mess. So the diodes prevent any backfeed going to the other ones and turn them on. That's basically just taking, obviously, only one would be running at one time, so it'll come in and then it'll come back out. And this, in this instance, is this yellow wire, and this yellow wire is the trigger wire to the MOSFET, which is upside down that we can't see. This is the back of the MOSFET. This is where the heatsink is. And we turn it over without snapping it. So there you go. There's the MOSFET. And one of these black wires is one from ground, and one is the output to the actual, well, in our case, bulb, but it will be a fan at some point. And the other bit on there, there is a resistor across the ground. Hold on, let me try and... So there you go. So resistor attached to ground and trigger, and that's just so it turns the MOSFET off quickly. Because the MOSFET, well, it needs a resistor. It needs a load to help turn the MOSFET off, so we can switch it fast on and off, which is what we're doing to achieve different voltages. So just 3 MOSFETs, one for the fan, one for the pump, and one for the glow plug, so we can make it run at 10 volts. Because, yeah, you could just have the glow plug switched directly and give it 12 volts, but it's not going to live very long. Because in the Webasto CEZ here, I remember I tried to look for just buying a replacement glow plug, and it was £60 for just a glow plug. Now I can only find it as a glow plug and burner chamber assembly for £100. So even if we were to melt through like 50p MOSFETs, or even like £1.20 modules running the glow plug, I'd rather melt through them than £100 worth of glow plug and burner module. So it's the same story on the pump side. Start, low, high, each has a trigger wire. Trigger wires coming out this block. It's got 3 ins and 1 out. The output drives the MOSFET, which drives the bulb, which isn't a bulb, it's going to be a pump. It looks a lot more complicated than it really is. It's basically just this big switch here. All your positives are on one side, and as your switch goes round, it just goes out to a different positive. So that's cool down. So that's in like position 1 on the switch. There's nothing on this side, and then cool down out to the other side does cool. Position 2, which would be start, it's got one for start, one for the low pump speed. Oh, sorry, the start pump speed. One to run the glow plug, and the other one goes out to tell the fan on start, and same again, or so on and so forth. There will be a wiring diagram at some point once I work out how to draw one nicely in something. As well, Andrew drew me a very nice hand-drawn sketch and handwritten notes for the wiring and the electrical diagram, but having it laid out in a better format would perhaps be more useful to people. So what I should do now is convert all of these bulbs into a heater, and then we'll try running it, and we'll see if it goes on fire or not, and see what happens. Right, I'll bring you back once I've set the monstrosity up. Okay, boys and girls, everything is attached. I haven't run it yet at all, so if it catches fire, if anything catches fire, we'll get to see it on camera, and it'll happen in real life. All the bulbs are removed. They've been replaced by the glow plug, the fan, and the fuel pump. Okay, technically the only thing I ran was the fuel pump to kind of prime it a little bit, and it sort of mostly worked. So we're going with that for starters. The only addition to the fan and the fuel pump is the inclusion of a diode across the positive and negative, so the pulse doesn't go back into the MOSFET and murder things. But that's the only addition so far, is the inclusion of a diode. I'm just putting cardboard in between the things and the bench so as not to short anything out on our first go. I've got the water pump ready just in case it actually somehow lights, but hey, let's not not going on fire is priority here. So stage 1 should turn on. and the fan runs. I don't know what voltage. Sounds quite fast. Right, let's go. Let's go for start. Go. Oh, we've got smoke. I think the fan might be too fast. Yes. Okay, we're making smoke. Right, we're making smoke. That means the glow plug's working. Happy days. Right, I did have a twiddly screwdriver. Twiddly screwdriver. Twiddly screwdriver. So, what we'll do is we'll take the pump. Perhaps I should put the extractor fan on. Let's take the pump out of the equation just now. Which one's positive? You're positive to the pump, so we'll remove you for just now, and the pump won't run. That's what we want. And we'll take the glow plug out as well, because we don't need it to run either. Which one's the glow plug? You're the glow plug, right? You can just not run either. Right. No glow plug, so we will turn it on and bring down the fan speed for start. No, that was the fan you disconnected. Yeah, no? No, you did disconnect the fan. You're an idiot. That's a glow plug. Right, that one is a glow plug. You stay there. This one is a fan, and we need that to run. That's the fan. It's the fuel pump I want to take out, which is this one. This one? This one. Where is the multi-plug for the... That's the fuel pump. Right. Disconnecting fuel pump. Fuel pump disconnected. So we have glow. No, we've got no glow and no fuel pump. Just fan. Right, go. So, let us take the voltage of the fan down. A lot. One of these makes it turn down. That was too much. That's really low. Let's see if we can get it to stay at that. No. Some bitch. No. It won't stay at a really nice, consistent. Still seems fast. Right, let's try again. Let's plug everything back in. This one is the fuel pump, and glow plug. Okay, cool. Start. Still lots of smoke, but no lighting. Still think the fan's too fast to light. Nope, it's lit. It's lit. Ah! Quick, put the pump on. Okay, it's lit. Let's try going to low, see if it blows out. Still lit, I can still hear it. Let's let it run for a few minutes. Is it getting warm? Still running. That's running on low. I think it might be just about to flame out. It has flamed out. Okay, we'll let it cool down. Cool down, I don't think it was ever really hot. So, from that brief experiment, well, we got it to start and light, and for low, I either need a slower fan speed or more fuel pump, and that is where the adjustment screwdriver comes in. So I'm going to fart about off camera just now and see if I can add a little bit more fuel into the low side and see if I can get it to run stably at that. Right, I'll bring you back. Okay, well, it seems to be running stably at low now. It's maintaining a stable burn, it's still going. Without it set up properly, I can't get the CO meter to tell me if I need more air or more fuel. Ideally, I need like also the exhaust temperature probe so I can poke it in and see if the temperature's going up and down. So I know if I need, again, more fuel or more air or less air, more fuel, you know, the balance. I haven't switched into high yet. But well, right now, fuck it, let's go high. Let's see what happens. Here we go. Ready? Go. I'm listening. It doesn't sound like it's flamed out. A lot more smoke though. It doesn't sound too bad. Ah, there she goes. So we'll just leave that and cool down to vent the smoke. Perhaps I should turn the extractor fan on. Extractor fan on! Hold on, I'll turn the extractor fan back off so that you can hear me. Go. Box up fan off. Oh, hello. Did you just ping off because you're hot, or did you ping off because are any of these things hot? Oh, holy ball! Jesus wept. Well, the glow plug MOSFET is red hot. In fact, so hot it's melted the solder. Woo! We're on fire, boys! Ah! I've managed to short out MOSFET again. Ah well, one dead MOS. All still works though. Okay, I've burnt my finger and have made the glow plug MOSFET very, very unhappy. So unhappy, in fact, that the middle lead has unsoldered itself from the doodah, which isn't entirely unsurprising, seeing as I've got great big leads going to the glow plug, and it's like a 10 amp load, and some of these wires are really thin, but I don't know why it was red hot like just now, because it's not doing anything just now. It should be off, as in not doing anything. It's so hot, it is melting the plastic of the insulator. I'm saying insulator. Wow, I've really set this fucking far. Let me just disconnect the whole thing. Bad things have happened to this poor MOSFET. Let me bring in and show you. I have murderized at least one MOSFET in this project. Look, at his little sad melted corpse, and he has unsoldered his own connections, and I've managed to like turn one of the leads of the resistor into a fuse wire. Wow. Sorry. Anyway, that's why MOSFETs are cheap, and you buy them by the bag, and then you just keep soldering them in and out for experimentation. Okay, what have I learned from this brief foray into adventuring? Right, let me just disconnect everything, because hey, there's no fuses here. We die like real men. Right, everything's unplugged and off. Okay, main power disconnected. Splendid. Still haven't managed to turn that fan off with smart technology. On. Off. Hey, there we go. Right, it's off now. What have we learned? we've learned that it works. In principle, you can absolutely use a bunch of components and a big switch and turn your diesel heater into a diesel heater, turning it on and off and making it do things and adjusting it with a screwdriver. I have also learned that the pump gets hot as balls, and the only reason that hasn't melted is because there's relatively cool diesel going through it. Now I expect that is because these cheap-ass 555 PWM modules, the on and off time isn't adjustable. So you're basically dead shorting the coil in this for every on stroke. So it's, instead of being a quick pulse of on, it's like on, off, on. Whereas we want it to be like on, big long off, on, big long off, on. And we're not getting that. So we'll need to think and try and come up with something to make it a pulse to the fuel pump. So it's just a pow on, pow. So it's just a single pulse of fuel, because we do not, well, as I say, dead shorting the coils in your fuel pump makes it hot and will kill it. Ask me how I know, because not just from this, I know dead shorting your fuel pump makes it very, very angry. But that is a thing that can be solved with more electronics. I'll need to ask Andrew if he knows why my glow plug MOSFET decided to commit suicide while it wasn't in use, which is interesting. I mean, all the other ones are, that one's cool, they've been all right, and they're the ones that were doing the switching and the pumping. It might, like I say, it might just be enough too small wires and too much load for it. But that's another problem that can be solved with bigger MOSFETs, etc., etc. So that's how far we are just now. And next time, hopefully, we'll have solved the dying MOSFET and the fuel pump issue, and then I'll try and set this up better so I can get like probes into exhaust and get the CO meter and try and get the fan speeds dialed in a bit. I'll need a bit more control over the fan speed. I need to speed up and slow down better. But we've got this far, and it's a thing, and we will continue on. But at the moment, any questions, comments, so on and so forth, leave them in the comments, and I'll, as always, try my best to answer them or point you in the direction of someone else who can answer the questions. And as always, thanks for watching.